All right, here we go with a walkthrough of the study guide for 8B. We're looking for the center and radius of this circle with this equation. So let's compare it to the standard form of an equation, which would be x minus h squared plus y minus k squared equals r squared. So comparing that, we know the center of a circle is the value hk. The radius is, of course, the r value, which is the square root of what you get there. So knowing that the formula has a negative in it, if my center, then my h value would have to be negative 21 to make a result of positive. And then negative 15 would be a positive 15. And then r squared is 961, so the square root of 961 would be the radius. And that happens to be 31. The square root of 961. Okay, so that's all you need there. Write the equation of a circle that has a center at, so now we're going the opposite direction. We're given the center, so that's h and k, and a radius of the square root of 139. All right, so let's fill that back in. We have x minus h is a positive 14, squared, plus y minus, it's a minus, so minus a minus is positive, squared equals, the square root of something squared is just going to be 139. And if you take a square root of something and then square it, you're back to the answer you started with. So that would be the equation that matches that. Now graphing, we have, again, we're going to pull out h is negative 1 and k is 0 because there is no k value there. The radius would be 4. So at negative 1, 0, radius of 4, 1, 2, 3, 4. I'm going to count 4, 1, 2, 3, 4 in every horizontal and vertical direction because I cannot 2, 3, 4 count 4 on a diagonal because that would be a different length. So get your points and try to connect them in a circle. All right. Now the opposite of that is looking at a graph and finding its center and radius so that we can write its equation. So center is going to be the coordinate 3, negative 5. The radius, I'm going to count 1, 2, 3, 4 from the center. So rebuilding that equation, we have x minus 3 squared plus y plus 5 squared equals the radius squared, which is 16. All right, moving on. Now we have 2 points. We have negative 2, 7, which is the center. So I'm going to go ahead and label that HK. And another point on the circle, 0, 5. So that is just a random point on the circle. So that is going to be represented in the equation as XY. It's just a point out on the circle. All right, so what I'm going to do is plug this in. I'm going to rewrite it so we have it in front of us. What we are doing, y minus k squared equals the radius squared. So I don't know the radius, but I have an hk. I have all these other values, so I can plug in everything and then solve for the radius. So I'm going to be very careful. Label these so you don't get them mixed up, and I'm going to put them right into the equation. 0 minus a minus 2 squared plus 5 minus 7 squared equals the radius squared. All right, so let's keep working to get the radius, the values. 2 squared is 4. 5 minus 7 is negative 2, but when you square negative 2, you're going to get 4, and that equals the radius squared. So 8 equals the radius squared. Now, we can stop there because Well, our goal is to rewrite this equation. So I'm going to write it leaving now x as a variable, because remember, in a circle, this is your xy out here. You have one center, you have a constant radius, but the xy values are made up of many, many different points. So that needs to be a variable. X minus, and I'm going to actually, you can just refer right here. It's going to be the same thing. Plus, instead of 5, I'm going to write y minus 7 squared equals, what is a radius squared? 8. And you're done. Leave this as the final answer. On y'all's quiz, a lot of people just left it here. So we don't want to do that. We want to continue on and get a final answer right here. And that was 5. Let's find 6. Okay, this is when we have to complete the square. We're going to put it into standard form. Again, we are looking to do this. Y minus k squared equals the radius squared. All right, so this involves completing the square. So I'm going to stay nice and neat. I'm going to gather my x terms together. They're on the same side of the equation, so I don't need to change any signs. I'm just switching their place. I'm going to have my y squared minus 32y switching their place, but this 264 needs to move to the other side. So I'm going to subtract it from both sides, and that's going to equal negative 264. All right, next up, I'm going to find out what needs to go here and what needs to go here, and I'm going to build my formula back here. All right, so I know it's going to be x and y in this space. I'm going to take half. These are my important numbers. Half of the middle is my factor. I'm going to square that. Negative 3 squared is positive 9. That's what I've introduced into this equation, so I need to add a 9 to both sides. Here, half of this is negative 16. Square negative 16, and let's see what that equals. 16 squared is 256. 256, so I'm going to add that to both sides. And then I'm going to get a total for all of that. So 256 plus 9, and I'm minusing 264 equals just 1. All right, so it said find the center and radius, so we're not going to stop here. We've got it in standard form. The center is going to be HK, so 3, 16. My radius is the square root of 1, and that is just 1. All right, looking good. Another one, so 2 of those, another one just like that one. So we've got to rearrange again. On my x squared is already on the left side, so I'm just going to rewrite it where I want it. My y squared needs to move, so I've got to add plus y squared to both sides. My 16 needs to move, so I'm going to minus 16y to both sides. And my 31 is in good shape. I'm going to leave it there. All right, so I'm going to build my factors. I'm going to take half of my middles. So divided by 2 is 4. 4 squared is 16. Add that to both sides. Half of my middle is negative 8. Square it. Add 64 to both sides. And total this guy. So I'm looking at 31 plus 16 plus 64 equals 111. I wonder if that is, let me re-enter that. I wonder if that's supposed to be 121, but maybe not. Plus 16 plus 64, 111. Okay. Make sure I didn't make any mistakes. 8 and 8 is 64. 16, we're adding 16 and 64. Okay. Square root of 111 is, don't believe that's a perfect square. I find my square root button. Yeah, so that's going to be a fraction of some sort. So we've got the center is -4, 8. The radius is, we could say the square root of 111, or when I work that out, I get 10.54. So that one didn't come out even, but I don't see a mistake. We'll see if we catch it later. I would have thought they might have wanted that to be 121. Oh, wait. No. No. All right, we'll go with that. All right, now this is new stuff. So we are graphing the dilation of the circle with this rule. So the translation is going to tell us, all right, so we're going to take our center, we're going to move it 5 units to the left. 1, 2, 3, 4, 5, and 3 units down. 1, 2, 3. So this is our new center. The scale factor is a 5:2 scale factor. So the new, that tells me this, the old, the pre-image, I guess you would call it, is the radius of 2. So that's where this is, the pre-image. The pre-image, and the image is the after, so its radius needs to be 5. So I'm going to count 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, and all of that makes one big circle. Overlapping the other circle. Okay. And all right, so we have a translation, and we have to find what the rule was and the scale factor. So we went from F to F prime. That means we went 1, 2, 3, 4, 5, 6, 7, 8. We went a -8 in the X direction. We went a -2 in the Y direction. And our pre-image is radius of 1, 2, 3, 4. Our image is 2. Image on top. So a 2 to 4, which could be reduced to a 1 to 2 scale factor. Okay. All right, I'm just noticing those aren't labeled, but they've got F and F prime. They don't call them circle C and circle A. All right. Oh, last one. Easy stuff. Convert 120 degrees into radians. No decimals will be accepted. That is going to be the hardest part of this. We have 120 degrees. We want to convert it to radians. So remember our conversions. If we're going to radians, we want the radians on top and the degrees on bottom. If we're going to degrees, we want degrees on top, radians on bottom. So we're going from degrees to radians. So I'm going to multiply this by pi over 180. And I need to reduce this fraction and not just divide it in a calculator. So I know 120 over 180. Well, right off the bat, I'm going to reduce that 10. Now I've got 12 over 18 pi. I know 12 could be 4 times 3. I know 18 could be well, 9 times 2 or 3, 6 times 4. No, that's 24. What am I thinking of? Let's see, 9 times 2. That would be 3 and 3 and a 2. All right, well, and that's 3 times 3. So we can reduce the 3 and we can reduce the 2. And that's going to leave me 2 over 3. So it's a 2/3 pi. Yeah, so when you're reducing like that, you're having to just find your common factors and cancel out as you go. The other way, we talked about in your calculator, there might be a way to do this. 12 divided by 18. And there's a decimal to fraction button, but I tell you what, I don't have your calculator here with me, so we'd have to look at that in class. But anyway, you're going to need to be able to reduce your fraction. That might be the part we'd want to look at some more. Okay, so the main thing is your conversion factors, and I have a feeling usually radians are expressed in fractions and not decimals, so we want to be able to reduce this fraction. Alrighty, sounds good, and y'all have a great evening or afternoon or whatever time it is for you. Talk to you later. Bye-bye.